Okay, so the final part, we said hence show that cos 2 pi over 5 plus cos 2 pi over 5 plus cos 4 pi over 5 is equal to minus a half. Now, when doing this problem, one of the things I'm going to do, and this is probably a good idea generally, is to use this word cis or kiss. I don't know which one I should do. Kiss, let's use kiss, why not? Kiss theta, which is cos theta plus I sine theta. Now, in these circumstances, therefore, as I said, omega 4, 3, 2, and 1 is the equivalent of just changing this power 4, 3, 2, and 1, and therefore omega to the power 5 is kiss 2 pi over 5, cos 2 pi over 5 plus I sine 2 pi over 5. Omega to the power 4 is kiss 2 pi over 5 plus I sine 2 pi over 5 to the power 4. And so here you can see all the kisses. There's 1, 2, 3, 4 kisses in the plus 1 as is described there. I then used the Moivre's theorem, and I therefore pop logarithmically, if that's the correct discourse to use there. It's absolutely not, I'm lying. But I end up with this there. And so what I'm going to do then is I'm just going to do the following. I can see that, and bear with me for a moment because you'll probably be considering why am I doing it this way. But I'm using the shorthand. I took all of this and then I ended up with that, which we could have used for this question. We could have used that for this question, but my position was, I'll show you a more peaceful way, and I'll utilize this concept later. So we know that this is the case. This here, I'm going to rewrite at the top of this on a fresh page. So there we have what we just did, what I've just described. We now have to recognize the same thing that I said earlier about arg. Arg has to be between minus pi and pi. And to sort that out, knowing that there's a cycle to the correct value could be said to be a cycle 2 pi away, then we can use this correction here. So I can simply say, well, if I put a minus 2 pi in here and a minus 2 pi in here, these ones are fine. They are not outside of the definition of arg between minus pi and pi. But if I put that in, and another way of viewing it is similar to considering the negative side of k, but this is what I would describe as a correction to make sure that it's within the correct value of arg. Then I end up with this here, like so. There you are. I'm going to expand it out now. So this is cos 2 pi over 5 minus I sine 2 pi over 5. Expand it all out. And what you will notice is the extent to which things start cancelling out. So you've got cos and cos 2 pi over 5. You also have I sine 2 pi over 5, cos 4 pi over 5, I sine 4 pi over 5, cos 4 pi over 5 plus I sine 4 pi over 5, and this will be cos 2 pi over 5 plus I sine 2 pi over 5. A lot of those will cancel out. What will cancel out in particular is the I sine 2 pi over 5, and it will leave you with 2, because there's a cos in there, and there is a cos in here, 2 pi over 5, and there is a cos in here, and there's a cos there, and there's a cos in here. If you take your time and write it out smoothly, you'll find that you end up with this. 2 cos 2 pi over 5 plus 2 cos 4 pi over 5 plus 1. Now, given that, and this is where things get a little bit smoother, given that I've had enough pink for one day, given that we know this is equal to 0, we've proven that, and we can even visualize what that looks like by way of the vector description that I have given you in the past. So it would be 4 vectors connecting in on each other, if vectors would be the right word to use there, then I can make this equal to 0. And if I make this equal to 0, I can bring minus 1 on both sides, and then I can divide through by 2, and there you have cos 2 pi 5 plus cos 4 pi over 5 equals minus a half there. Thank you very much for staying with me on that one if you did.